Heart and blood vessels. Part 4, blood pressure. Blood pressure. Blood pumped by the heart through the arteries is under pressure. Elastic connective tissues and smooth muscle tissues stretch to accommodate the blood and then recoil. The alternating stretching and recoiling help to push blood along. Measuring blood pressure. A Slinkman meter and a stethoscope can be used to measure blood pressure. A Slinkman meter is a cuff with an air pump and a pressure gauge. The stethoscope is a device that detects faint sounds. We'll use both of these instruments on Monday and Tuesday. Taking blood pressure. The cuff is wrapped around the arm and pumped up to a pressure greater than 120 millimeters. The stethoscope is placed under the gauge of the cuff, and the pressure of the cuff is decreased slowly until the first lub is heard. The pressure is then recorded. It represents the pressure when the ventricles contract and is known as the systolic pressure. The pressure is further decreased until the sound disappears, and this pressure is recorded. This represents the heart at rest and is known as the diastolic pressure. Normal blood pressure. Normal blood pressure is approximately 120/80, meaning the systolic pressure is 120 and the diastolic pressure is 80. Blood pressure decreases as the distance from the heart increases. Effects on your arterial size. Products of metabolism can affect the diameter of arterioles. So during cellular respiration, sugar is in the presence of oxygen, carbon dioxide and water form. And in the absence of oxygen, lactic acid forms. Carbon dioxide and lactic acid are the two substances that cause smooth muscles to relax and the diameter of the arterioles to get larger. This increases the blood flow to most active tissues. The increase of blood flow brings needed nutrients and oxygen to these active areas and carries away waste products. Regulation of blood pressure. Blood pressure, which is too low or too high, is dangerous. The nervous system helps to overcome these situations. During periods in low blood pressure, the sympathetic nervous system causes cardiac output to increase and blood pressure to increase. During periods of high blood pressure, the parasympathetic nervous system sends messages to the heart to decrease the heart and stroke volume, which in turn decrease cardiac output. This slows blood movement and blood pressure will drop. Cardiac output. Cardiac output is the amount of blood that flows from each side of the heart per minute. And the amount of blood pumped from the right side is equal to the amount of blood pumped from the left side of the heart. It depends on two things: your heart rate and your stroke volume. So we can put this into a mathematical equation where our cardiac output equals heart rate times stroke volume. So if we have an average 70 beats per minute, and in that minute per beat we move about 70 milliliters of blood, this means that we can move almost 5 liters per minute of blood through our body. And the average adult does pump 5 liters of blood per minute. Cardiac output adjusts to meet our energy needs of our body. So during exercise, our heart beats faster. The contrary, during sleep, our heart will beat slower.